Welcome to Module 6, where we will be exploring exponents and exponential functions. Two major vocabulary words to remember in 6.1 include monomial and constant. A monomial is a number, variable, or the product of a number and one or more variables with a non-negative integer exponent. A monomial is always one term, hence the term mono. A constant is a monomial that is a real number. Examples of monomials and constants are listed right here. Three key concepts to remember in 6.1 include product of a power, where when multiplying if the two powers have the same base, you add the powers. The second one is power of a power. When the expression or monomial is in the parentheses and the exponent is outside, you multiply the exponents. Power of a product. To find the power of a product, find the power of each factor and multiply. There are two vocabulary words you need to keep in mind with these two. Zero exponent. A non-zero number raised to the power of 0, which it will always equal 1. And negative exponent. Any non-zero real number raised to a negative power. There are four major concepts you need to remember for 6.2. The first one is quotient of powers. To divide two powers with the same base, subtract the exponents. The second one is power of quotient. To find the power of quotient, find the power of the numerator and the power of the denominator. The third concept is zero exponent property. For any non-zero number raised to the zero power is equal to 1. The fourth one is negative exponent property. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. Four of the vocabulary words you need to know are rational exponents, the use of rational numbers as exponents, where for any non-negative value of ab over c equals c times the square root of ab. Cube root, the number that produces a given number when cubed, where 3 to the third equals 27. So the cube root of the third one is nth root, where n times the square root of x. And the fourth and final, exponential equation, an equation in which a variable occurs as an exponent. The first one is power property of equality. For any real number b that is larger than 0 and does not equal 1, b to the x equals b to the y, if and only if x equals 1. The second one is converting radical to exponential form and vice versa. To convert radical to exponential form, first use a number for the root as the denominator for the power. Then use the number of the number in radical form as the numerator. If the number is not raised to a power, it is by default raised to the first, so put 1.
Created using Powtoon.
6.4 Scientific Notation. Scientific notation, vocabulary to remember. Scientific notation, a number written in the form a times 10 to the x, where a is larger than 1, yet smaller than 10. Scientific notation, key concept number 1. Standard forms of scientific notation. Step 1. Move the decimal point until it is to the right of the first non-zero digit. The result is the real number a. Note the number of places that you move the decimal point is n. Step 3. If the decimal point is moved to the left, write the number as a times 10 to the n. And if the decimal point is moved to the right, write the number as a times 10 to the negative n. Step 4. Remove any unnecessary zeros. Key concept number 2. Scientific notation, the standard form. Step 1. In a times 10 to the n, note whether n is larger than or smaller than 0. If n is larger than 0, move the decimal point n places right, and if n is smaller than 0, move the decimal point n places left. Step 3. Insert zeros as needed. Now on to 6.5. 6.5. Exponential functions. Vocabulary to remember. Exponential function. Y equals ab to the x, where a doesn't equal 0, b is larger than 1, and b does not equal 1. Note that they are nonlinear. Exponential growth function. Y equals ab to the x, where a is larger than 0, and b is larger than 1. Exponential decay function. Y equals ab to the x, where a is larger than 0, and b is in between 0 and 1. 6.5 Exponential functions. Key concepts. Graphing exponential functions. To review, x is domain and y is range. In exponential growth, the graph goes up, and at decay it goes down. The range y that approaches but never reaches 0. Graphing exponential growth. No x-intercept. As the domain x increases, the range y also increases. As the domain decreases, the range approaches but never reaches 0. Note that the graph is going up. Graphing exponential decay. No x-intercept. As the domain x increases, the range y approaches but never reaches 0. As the domain decreases, the range increases. Note that the graph is going down. We're almost there, just hang in there. 6.6 Growth and decay. Vocabulary to remember. Compound interest. Interest earned or paid on both the initial investment and previously earned interest. 6.6 Growth and decay. Key concept number 1. Equation for exponential growth. Base equation. Y equals a times the sum of 1 and r to the t, where y is the final amount, a is the initial amount, r is the rate of change expressed as a decimal, and t is time. Key concept number 2. Equation for exponential decay. Base equation. Y equals a times the difference of 1 and r to the t, where y is the final amount, a is the initial amount, r is the rate of change expressed as a decimal, and t is time. Key concept number 3. Equation for compound interest. Base equation. A equals p times the sum of 1 and r divided by n to the nt power, where a equals the current amount, p is the principal or initial amount, r is the rate of interest expressed as a decimal, n is the number of times compounded each year, and t is time. And that's it. You made it. We hope you enjoyed, and thank you for watching. Sponsored by AMS Mass Productions, making high quality video productions since, well,